Wait, they don't love you like I love you. Wait, they don't love you like I love you. Nah.
Hello guys, today our group are going to present about the friction. So, what is the friction? Friction is the force that resists the movement of two contacting surfaces that slide relative to one another. It acts tangent to the surface at points of contact with other body. In this project, we are going to show you about the friction when pushing the weight rod. Also, there are two boxes on the weight rod too. Does the weight rod slip or tip when pushing on it? We are going to show you the result by free body diagram, center of the system, and also rigid body equilibrium. So, let's go!
Woi, tunggu. As we know, pushing force P is acted towards the left. Since the wardrobe is on the floor, there will be friction force, as we will label as FA, which is towards the right. We will also label the wardrobe weight as WA, which is downwards, and when there is weight towards downwards, there will also be a force, normal force acting upwards. The two boxes will be labeled each as WB and WC. And now is the calculation for WA, which is equal to 90 kg times 9.81 equals to 882.9 Newton. And for the friction force FA is 0.3 MA, which is the static coefficient is 0.3. And WB and WC is equals to 10 kg times 9.81 equals to 98.1 Newton. And that's all for my free body diagram part. Let me pass it to my next friend.
Excuse me, has anybody seen a white rabbit?
Okay, I will talk about the centroid and the center of gravity of our structure, which is wardrobe and two boxes. First of all, we'll divide it into three different segments, which is 1, 2, and 3 as above. For the calculation of centroid of the structure, first of all, we need to find the area and the coordinates of centroid of each segment as we find above, and we need to apply it into the formula as shown here, and we get that the coordinates of the centroid is 0.496 and 1.042. And for the calculation of center of gravity, firstly we need to find the weight of each segment, and then we need to find the coordinates of centroid of each segment. After that, we apply this value into this formula, and we get that the center of gravity coordinates is 0.482 and 1.2, which is slightly towards the left from the centroid of structure.
So Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. So in this video we're going to explore the concept of rigid body equilibrium through a particular example involving a wardrobe and some external forces. We know that the rigid body equilibrium is an important concept in physics and engineering, ensuring the objects remain stable and balanced under applied forces. So let's dive in and see how this applies to our scenario. Let's go. First of all, the problem. What is our problem? So let's take a look in this picture. So here's the setup. We have a wardrobe with a mass of 90 kg resting on the floor. So the floor has a static coefficient of friction of 0.3. On top of the wardrobe, there are two boxes, each with a mass of 10 kg. So these boxes are fixed on top of the wardrobe, and there's no friction between the boxes and the wardrobe. So now, a horizontal force P. You see that P? So this horizontal force is applied to the wardrobe. So our goal is to determine whether the wardrobe will slip or tip under the influence of these forces. So if we take a look in this picture, we know that there's a lot of value that we don't have. So how to solve it? Let's follow the steps. So first of all, write the equation of equilibrium. So we know that equilibrium in the vertical direction, we assume F1 equal to 0. So first of all, write the first equation this first. We know that the weight of the wardrobe is 90 kg. So the equation is W equal to 90 kg times 9.8. So we get 882 Newton. Next, the weight of each box. The weight of each box is 10 kg. So we times by 2. So we got 20 kg times 9.8. So we got 196 Newton. So from weight of the wardrobe and weight of each box, we can calculate the normal forces, which is at A equal to weight of wardrobe plus weight of each box at equal to NA. So we just put it in the equation, NA equal to 882 plus 196 equal to 1078 Newton. So that's for the vertical equilibrium forces. Next, we go to the horizontal directions. So first of all, write the equation of equilibrium. We know that Fx equal to 0. So the equation is force coefficient minus horizontal force P equal to 0. We know that the force coefficient is 0.3 and times by NA minus P equal to 0. Next, P equal to 0.3 NA. NA, we just put it back in our equation, which is 1078. So we got 323 and 4 Newton. Next is the equilibrium of moment. So we know that FA equal to 0. So the equation is P times 1 minus weight times X equal to 0. So we know that the horizontal force P is 323.4 times by 1 and minus the weight is 9.81 times X equal to 0. So we know that X equal to 323.4 divided by 9.81. So we got X equal to 0.3. So the result is, since the static coefficient of friction is 0.3 is less than the vertical value, which is 0.4. So the wardrobe will slip before it can tip. So the applied force P will overcome static friction at 333.4 Newton. So this will cause the wardrobe to slide rather than tip over. So I think the conclusion of this example highlights the importance of understanding forces and moments in rigid body equilibrium. So by applying the principle of equilibrium, Fy equal to 0, Fx equal to 0, and Ma equal to 0, we determine that the wardrobe will slip due to the insufficient static friction. So I think that's all for me. Thank you for watching, and I hope this example helps clarify this principle. Thank you.